All right, so today we're going to start 9.5, which is all about the dot product. So if I give you two vectors, a comma b and a comma b, then the dot product, v times w, and that's not times, it's dot w, is defined as a times a plus b plus b. So for example, if you notice here, these are vectors because we have our vector notation. This is not a vector, right? There are no vector notations here, and it's not a comma between these, we're adding them. So the biggest mistake I see people make all the time is that they say the dot product is a vector, and it is not a vector, it is a number, not a vector. Okay, so the dot product of two vectors is like 7 or 10 or negative 40. It is not a vector a comma b. So I see people make that mistake all of the time. Now keep in mind too, we don't multiply vectors, we take the dot product of vectors, right? So I will never say, here's this vector, multiply it by another, okay? We will do dot product, but not multiplication. So for example, in number 1 here, it says, if v equals 2i minus 3j and w is 5i plus 3j, find the dot product of v times w. So to find v times w, we're going to multiply our x values and then multiply our y values and add those two answers together. So we're going to do 2 times 5, those are our x values, plus our y values multiplied together. So that gives us 10 plus negative 9, which is 1. Okay, where I see people all the time, they say the answer is 10 negative 9, Ms. Peck, and that is wrong. Okay, dot product is a number, not a vector. Okay, so please make sure you're adding them together. Now you're probably wondering, what even is dot product? What does this number represent? And to be honest, we don't really find a dot product to help us find anything specific about the vector. We find dot product to find other applications of vectors. So for example, knowing that the dot product is 1 isn't really going to help us very much. However, if I gave you two vectors and I wanted you to find the angle between, you would have to do the dot product. So the dot product more is used within formulas that tell us information, but not necessarily 1 doesn't really tell us anything. But using the number 1 in this formula would tell us something. Okay, so how we use dot product, like I said, is to find angles between two vectors. So if I gave you the vector 4, negative 3, and I'm just going to kind of draw us a little picture just to give us a visual. So 4, negative 3 would be right here. And then 2, 5, so maybe that's like right here. I want to know this angle right here. Okay, so I want to know that what angle is formed between those two vectors. So I don't want to know the angle of this and the angle of this separately. I want to know the angle they create when they're together. And that formula is found by this guy right here. So it says we need to do the cosine inverse or cosine theta of u dot v divided by the magnitudes. Remember, these mean magnitudes. So let's find all of those pieces of information. So first let's find u dot v. So that would be 4 times 2 plus negative 3 times 5, which is going to give us 8 minus 15, which is negative 7. So our dot product is negative 7. Now let's find the magnitude of u. So the magnitude of u is the square root of 4 squared plus 3 squared, which would give us root 25, which is 5. The magnitude of v would be 2 squared plus 5 squared, which would give us root 29. Okay, so now that we have these three pieces of information, we can now plug it into our formula. So to find theta here, remember this is cosine, so to undo that we would have to do cosine inverse on each side. So we're going to have to do cosine inverse of the dot product, which we found was negative 7, over the two magnitudes being multiplied. I'm going to plug this into my answer, or into my calculator, and I will get the answer for theta right there. So we're going to do cosine inverse. Now I highly suggest we do the alpha y equals button to get the fraction, because if we don't, we're going to get the wrong answer if we don't use appropriate parentheses. Okay, because it's going to try to do, if you don't, it's going to divide and then multiply instead of multiplying and then dividing. So make sure you're using your fraction button. That gives us an angle of 105.068 degrees. Oops. Okay, so this angle right here between the two vectors is 105.068. Okay, so let's try B. So B is 5i plus 2i and 2i minus 5j. So we're going to first find the dot product. So we're going to do 5 times 2 plus 2 times negative 5. That gives us 10 plus negative 10, which is 0. Now let's find the magnitude of u, which would be the square root of 5 squared plus 2 squared, which would be the square root of 29. Magnitude of v, 2 squared plus 5 squared, which is also root 29. So then we're going to do the cosine inverse of the dot product over root 29, root 29. Okay, so if we plug that into our calculator, cosine inverse of 0 over root 29, we get 90 degrees. Which should make sense, guys, because 0 divided by anything is 0. So when I do cosine inverse of 0, on our unit circle, that's 90. So that should make sense that this answer is giving us 90. Okay, so if you get a dot product of 0, 0 divided by anything is 0. So if you get a dot product of 0 and you want to stop and say the answer is 90, that's fine with me if you remember that little shortcut, if you will. Okay, because that's just using your unit circle, and I'm okay with that. So, oops, flip the page. Why don't we look at C? So C is finding the angle between again. So let's do U dot B. So that'd be root 3 times 1 plus 3 times 1, which will give us root 3 plus 3. We can't combine those, so we just have to leave it just like this. I don't suggest making that a decimal. I suggest just leaving it as it is. Okay, now let's find the magnitude of U. So that would be root 3 squared plus 3 squared. Root 3 squared is just 3, plus 3 squared would be 9, so 9 plus 3 is 12. Magnitude of V would be the square root of 1 squared plus 1 squared, which is the square root of 2. Now I know this can simplify, right? We can break this down to be 2 root 3, but it's really not necessary because we're not circling this. This isn't my answer. We're just using it to find our answer. So if you don't simplify this, I would actually suggest you don't simplify it because it's just going to make your life a little bit more complicated. So let's find what our answer is. So cosine inverse of root 3 plus 3 over root 12 times root 2. So that gives us 15. Okay, so I'm going to leave D for you guys to try on your own. Please make sure you do this problem. When I'm about to go to the next problem, I need you to know what this answer is. So please make sure you pause the video and do this right now because we're going to talk about its answer down here. Okay, so the next thing is that we can know if vectors are parallel or orthogonal. So parallel, remember, just means it's vectors that would never intersect, right? So parallel means they don't intersect. Orthogonal is just a fancy word for perpendicular. Oops. Okay, orthogonal is just a fancy word for perpendicular. So if we want to know if vectors are parallel and orthogonal, two vectors are said to be parallel if the angle, so if our angle is 0 or if our angle is 180. Okay, so if I find my answer, I do cosine inverse of the dot product divided by the magnitudes, and I get an answer of 0, then we would say that the two vectors are parallel. If we get an angle of 180, then we would also consider the two vectors to be parallel. Okay. Two vectors are said to be orthogonal, which remember just means perpendicular, right? That means perpendicular. That just means perpendicular if the dot product is 0. Okay, so this is that the angle is 0. This is that the dot product is 0. Remember, when we did the problem, where was it? here, right, we got a dot product of 0, which meant the angle was 90, which should make sense. Perpendicular lines make 90 degrees. So it really should make sense to us then that if we get a dot product of 0, that would mean the angle is 90, which would mean that they're perpendicular, okay? But it's just kind of nice if you get to the dot product of 0, you don't have to technically find that it's 90 because you should know that this means 90. Okay, so these are actually the same angles that we just solved before. So this is the same A as on the last page. So we had gotten 1.105.069. For B, we had gotten 90 degrees because the dot product was 0. For C, we had gotten an answer of 15 degrees, right? And then for D, you were supposed to have paused and did that problem. So if you didn't, do it now. Okay, that we should have gotten 180 degrees. So if it wants to know, are they parallel, orthogonal, or neither? If I look here, it's 105 degrees. Well, 105 is not 0, it's not 180, and it's not 90, so that would be neither. 90 would be orthogonal. 15 would be neither, and 180 would be parallel, right? 0 or 180 is parallel. So on the next page here we have number 4. It wants us to determine if the vectors are parallel, orthogonal, or neither. So in A, if we remember that they're parallel, if our angle is 0 or 180, we know they're orthogonal if the dot product is 0, and then it's neither if it's neither. Okay, so U dot V here would be -1 times -1 plus 1 times -1, which is 0. Now remember, if we get a dot product of 0, that means the angle is 90 degrees, which would mean orthogonal. Okay, so I'm going to leave this one for you guys to do on your own. Remember, if you don't get a 0 here, then you would have to keep going. Once you get an answer for theta, then you would determine if it's parallel, orthogonal, or neither. But I want you guys to try this one on your own. Okay, so we've got 2 word problems, and then we are done with 9.5. So in physics, work is done when a constant force moves an object. Okay, so work is found by taking the magnitude of the force times the distance that it's going. Okay, so the magnitude of the force times the distance. When really we could say this all turns into the dot product, hence why this is a 9.5. So we really could take the dot product of our force vector dot the vector AB. So A is where it's starting, so A is our start, and B is our end, right? So if I'm moving an object that starts at this distance and ends here, then that would be the vector AB. It starts at A and it ends at B. So if we look at 5, it says find the work in foot-pounds done by a force of 2 pounds acting in a direction of 45 degrees. So this is telling us our force vector. So our force vector is going to be found by taking the force, which is 2 pounds, cosine the angle, which is 45, and then 2 sine 45. Okay, so that would turn into 2 times root 2 over 2, 2 times root 2 over 2, which gives us root 2 comma root 2. So our force vector is root 2 comma root 2. So we found this vector, now we need to find our vector AB. So it's saying that we're moving the object horizontally 4 feet from the start of 0, 0 to an end of 4, 0. So we're moving the object from A to B. So if I know A is 0, 0 and B is 4, 0, and I want to find vector B or AB, remember to find vector AB, we would do tail minus head So we're going to do B minus A. So we're going to do B minus A would be 4 minus 0, 0 minus 0, which would give us the vector 4, 0. Okay, so here's the force vector, and then here's where we're trying to move it. So now that we have our two vectors, if I want to find work, I'm going to take the dot product of those two vectors. So work is going to be root 4 times root 2 plus 0 times root 2. Right? So we take our x times our x plus our y times our y. That's how we find dot product, just like we did up here. Okay, so 4 times root 2 would be 4 root 2. 0 times root 2 is just 0, so 4 root 2 feet-pounds. Okay, so 6 says, a girl is pulling a wagon with a force of 50 pounds. Okay, so that's going to be part of our force vector. And it wants to know the work that's being done to move the wagon 100 feet if the handle makes an angle of 30 degrees with the ground. Okay, so our force vector is going to be found by taking our force cosine of the angle and then force sine of the angle, which I'm going to leave you guys to finish that. Make sure you simplify it just like we did here. Now, we're trying to move the vector 100 feet. So that's like saying we're starting at 0, 0, and we're moving 100 feet to the right. So that would be 0, 100. Or sorry, 100, 0. Put that wrong. So here's our A, here's our B. So our AB vector is going to be 100 minus 0, 0 minus 0. Okay, so now that we have both of our vectors to find work, I'm going to take the dot product of those two vectors. So I'm going to leave that for you guys to finish on your own.